So let's have a look now at the cooling water system, also sometimes referred to as the jacket water system. Now the cooling water system for smaller engines is optional, you will not always see it, but on medium and large size engines you will always have a cooling water system. This is for the same reasons as for why you have a lubrication oil system on medium and larger sized engines. It's simply because the engine generates so much heat that you need to have a separate system in order to cool down all the components. That is the sole purpose of a jacket water system. It is to cool down the engine, ensure that we do not overheat the engine. In this 3D model we can actually see how that occurs. So we've got our usual setup. You can see our combustion chambers, and there's our crankshaft. And if we go over to the side here, we can actually see a blue arrow. And if we go further along, we can see a few new components that we haven't seen before. So what is happening on this 3D model? Well, if I can angle this correctly, and if I push play, you'll see the blue arrows here, they represent cooling water. And this one over here is actually a cooling water pump. The cooling water pump pumps cooling water around the engine. When we start the engine is cold because we haven't generated any heat due to combustion. That takes a while. The engine has to be running for a little bit before we generate heat. So the cooling water that's being circulated now by the pump is coming out, it's coming along here, and we get to something called the thermostat. It's actually closed on the top, so the cooling water is going to come along and flow down this pipe, along there, and it's actually going to bypass the radiator. So if you follow my mouse for a moment, it comes along here, and the cooling water goes back there and circulates back to the engine, and then the process continues, and that's essentially what the cooling water system is doing when the engine is cold. The radiator is this item here, and I'll show you what the radiator is for right now, because we can push play and we'll see cooling water is being circulated, the engine's just sort of come online, might be running at a few RPM, sort of idling, gradually heating up. And as it gradually heats up, the cooling water is also going to get warmer and warmer. But we don't want to cool the cooling water just yet because we want the engine to be operating at a certain temperature, and that is the temperature that's most efficient for combustion and in order for the parts to operate effectively. If we cool the engine at this stage, we're actually just creating additional work and we're more or less sucking energy out of the engine. So we don't want that. We want the engine to be hot or warm, but not too hot that it seizes. Now in a moment, we should find, hopefully, that the colour of the arrows is going to change. There we go. And notice now, we're still circulating cooling water, but the cooling water is going, instead of down here, you can see it's actually blocked here, so we can't bypass the radiator any longer. Let me back it up a moment. See, the blue arrow is going down, bypassing the radiator. Gradually the temperature increases. The thermostat moves positions, closes off the bypass, and now the cooling water is so hot that the engine is saying we need to cool the cooling water down because otherwise we're going to overheat. The thermostat expands because it's been heated up, and then the cooling water is diverted to the radiator instead of bypassing the radiator. Let's push play again. You can see it's going up here and it's going to the radiator. If we come along here, you can see the red arrows coming down. They're passing through the radiator. I'm going to pause it for a moment. So the red arrow is passing down, 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 and they're passing all the way down to the bottom of the radiator, at which point the cooling water has been cooled down slightly, and then it will come along here and return to the engine. We're using air to cool down the cooling water as it passes through the radiator. You can see that here. Air is indicated by these white arrows. So air is being blown across the radiator by this fan. The fan would usually rotate, and as it does so, we're going to cool down the cooling water. So although it's not shown on this particular model, we should perhaps actually animate all of these parts to make it a little bit easier, but I think you can imagine the whole thing working. Let's imagine the piston's going up and down, the crankshaft is rotating, this fan is rotating, the cooling water is coming in, it's coming down this way, the air takes away some of the heat from the cooling water temperature reduces, and then it circulates back to the engine. And what we actually have is a way of maintaining the engine temperature at the desired, most efficient temperature. A jacket water system will usually be around 80 degrees Celsius and approximately 3.5 bar of pressure. But that's essentially how the cooling water system works. When it's cold, we bypass the radiator, and when it's hot, we cool the cooling water down to a specific temperature in order that we can maintain the temperature in the engine at the optimum temperature. We actually use cooling water jackets, and you can see those in this space here. And cooling water jackets surround the combustion space because that's where most of the heat is generated, and they will take the heat away from the combustion space. The cooling water system does not usually have any other purpose other than for removing heat from the area surrounding the combustion space. Let's load up a cylinder sleeve and I can actually show you that in greater detail.